Alright, so good. We have the struct here. The struct, we want to keep information on a player's first name, a player's last name. We want to keep information on when they were born, and what their position is going to be. We also had the file associated with this. Let me open the file. Players.txt, and we had these players inside of the file. And last class, what we did was that we just focused on adding a player, I believe, and we also focused on reading all of the players from the file and displaying the information from the file. To do that, essentially, when we read the information from the file, we had to create a struct array called list that could hold up to 250 players. When we have these 250 players, of course, we have the index being tracked with I. I is the index associated with this. I also tells us, if we look at it, I also tells us how many players are stored in this list currently. Okay? So we have our functions here, our menu function displays the menu, right? We have a messages function, displays a message based on the value passed to it. We have the read players function. This loads the file's contents into the struct array. View players allows us to display all players' info on screen. Add player, just like the name suggests, adds a player to the file. The player ID is automatically generated, right? And the last function, that we did was write players. This writes players info back to the file. But I know that we had an issue with write players last class. After we added a player, which it actually adds a player to the struct, when we call write players writes the information to the file, but the problem that we were getting was that we got that extra indentation. Not so? You all remember that when we ran it? So I think that is where we have to start today. Yes? That's where we have to start today. And then we could go on to searching for a player, or editing a player, or deleting a player. Okay, so when we call main, our menu is in an infinite loop. Our menu returns whatever selection was made. And from that selection returned, we call the appropriate function. If it is that a value was returned that is not associated with an appropriate function, then we send a message, either message 0 in the case of saying goodbye, or a message 1 in the case of saying we have an invalid selection. And the appropriate message would print out, and we would get prompted to show the menu again. Inside a menu, the first thing that we do is clear the screen, and then we will show the menu. So every time the menu comes up, it doesn't matter what was on the screen before. It doesn't matter what was on the screen before. We have to clear that. All right? And we start fresh with a new menu at the top of the page. This message function, as we said, takes in a value. So all messages in the system, we could use this to, just as a quick and easy way. If we have to make additional messages error messages in future, we could just change the number 0, 1, 2, 3, and according to what we put in there is what is going to come out. All right. This was a function to say, hey, we have more than 5 functions. You could have printed these messages out right then and there, but it's a nice, easy way to get your messages to print out. And, you know, I actually think this is better programming because now if you have to edit a message, you know exactly where to go as the programmer, okay? Right, this is the replayers function. We will have file FP, we open a file pointer, reading. Once we open a file pointer to read, we have to check to see if the file that it's pointing to is valid. Right? We set the name of the file, but I mean, if it is that you are writing a program, you could actually take in a string from the user and say, well, where is your file located? What is the name of your file? Or something so. Right? In this case, we have a set name, so players.txt. We have it in the same folder as the C file that is going to create the executable, so we don't have to put any path. Where are you going from here? Right, so as long as the file is valid, we reset list I to 0, and this is important because at this point we have no entries into the file. This 0 also tells us what is the next available position to put a value into. Correct? So while in equal to file in the file, while there is data in this file, right, we get a line of text from the file. If it is that the line of text was a line that is not the last line, then it will have a \n here, here, and here. We have to get rid of that \n. This is our code that does that. It says, hey, look at the last character in that line, and if it's a \n, turn it into a \0. Because we don't want \n's being stored inside of our structure, right? We just want the data that is there. We break that line up into tokens. Remember with tokenization, the first string tokenization that you do, you pass the variable name into it. All subsequent tokenization, so that you could continue from the last token pulled, you have to pass null. So we take out the first set of data, and that first set of data is this number. Of course, we read that token as a string. So we have to convert that token to an integer. Then we do we copy the name from the token, we copy the last name from the token, and we take birthday, birth month, birth year, and the player's position. And that is placed inside of list.position I. Come on. List.position I. Because we just established, we just said that list.position I is the next available position to store data. Once we read all this data into here, we have to prepare for the next, if there is going to be any more, we have to prepare for the next list.position I to be read in. So we say list.position I++. And once we have no more data to read in, we close the file pointer. Don't forget your close, because sometimes when you are doing file writes, the last set of data does not write properly if you don't clean off that. You know, that fclose is essentially a purge the memory buffer and make sure that the file on the hard drive is written as it should be written. All right. View players is easy. Once you read your players in, and you'll notice that every function that we do follows this pattern. Read the players into the struct, manipulate the struct as we see fit, and then write the information back to the struct. Well, for view players, we don't have to write the information back because this is kind of like a read-only operation. Yeah? To view, you only have to read. You're not manipulating anything. So read the players into the struct and then display it. But then for add player, we have to read, right? We work out what is the next available ID for a player that we put into the system. Then we start collecting data on this player that we want to put into the system, and we store it in the struct. We could have appended to the file, eh? And if you want to do that for your IA, that's fine. Because I'm not hard and fast about doing the things the way I show you. But I will admit to this. This is the more technical way to do it. Right? If you understand how to do it like this, and then I see you just use an append and stick that line at the end of the file, I'm not going to penalize you for that. You use your brain. You say, why Mr. Valdes make us do all this hard stuff? Right? You identify a solution to this particular problem. Okay? And then we write the players to the file. Right? So we write the players again from the struct to the file. We have the write player function, which was the last thing that we did last class. And all this really does is it says, okay, open a file for writing with the same name. We establish that once we open a file for writing, then all data in the file is removed. We write the contents of the struct to that file. And then we close the file. Okay? I think I might close the file before I put printf here. Because only after you do your fclose is when your file data was written successfully. Right? It's a very minor thing because there's little chance that between that fclose and saying that the file data was written successfully, that you'll get an error. But if I post to the screen that the file data was written successfully, and for some reason, out of the 1 million times that my computer should do it, I get a bug one time and it didn't get written successfully, I've already said to the screen, I've already said to the user that it was written successfully. Doing something like that, you all would not believe. You all wouldn't believe in terms of programming how just making that change in sequence there could save you, maybe I would say maybe in an extreme case, it could save your company from getting sued. And in a not so extreme case, it could save you from having some irate customer or employee calling the IT department and saying, I thought say it saves successfully, but I'm not seeing the data in the file. Why would it say that it saves successfully, but the data not in the file? Right? And then they talk to their boss, and I speak to Clement, and Clement see that it saves successfully, and I'm asking him, and he can't tell me why. Right? I'm telling you. Because that's how people are. Once you see something on the screen of a computer, you get that message saying that it did what it did, but it didn't do what it did in the case, And that could be the basis of somebody saying, well, I lose all my data, and they'll tell me the data was there. So, right? But if it just hung up at the fclose, then it doesn't get to the file data written successfully. And so that the user never sees that, and then that creates a different argument. It's why this didn't work, rather than why it said it worked, but it didn't work. Okay? So those are little sequence things that you have to think about. In both cases, it's correct. Well, let me not say it's correct. It's fine. But one is a little more correct than the other. All right? So, yeah. And, so last class we wrote what? 173 lines of code. The easiest 173 lines of code you'll ever write in your life. Not so? Yeah, Jarrell? Well, you see, if Jarrell say yes, it must be so. All right? Anaya, a lion? Yeah. I feel like going with Jarrell. Jarrell, Anaya is like with Kyra. I can't trust you. All right. Kyra, is it the easiest lines of code we ever write? Because you what? Yeah, well, that's what I'm saying. Kyra just, real eager to produce it herself. Well, it's the easiest lines of code that we ever write. No, you never type nothing. All right. So you see, to be fair now, I'll stop sending a little code. We'll talk about it in class. No, this is the argument that Omar is making. Right? I want Omar, and I believe Kyran and I also want it too. The argument changed. It's the easiest lines of code we ever write. Ah, okay. Omar? You was in the what? He was in the room. So we wrote it together. Right? Easy, simple. We want to fix this problem with the add player because, again, last class I went and fixed this manually. Right? I don't know if anybody was thinking about a solution. I feel like Alexandra was thinking about a solution to this, yes? Between last class and this class? Yes, no? What is Alexandra? Which one of you all is Alexandra? Not you. Oh, okay. All right. So let me ask a question. If this hurts my heart when Comsci not going on a little think about Comsci. Thank you, Clement. Oh, you didn't have time to miss it. So what you're saying is maybe I should take a day off at some point. After. Oh, okay. I get my days off there, July and August. Well, you see, that's the attitude that we supposed. And I'm laughing in the corner there. And are you laughing because you're just so much in agreement with what Clement is saying? Yeah, contain yourself, and contain yourself. Right? We need to get some work done. Alright. I'm waiting for the day where Kyra laugh from happiness. No? Oh, she probably has the biggest smile in the world underneath that mask right now. Alright. Alright. Don't worry, man. I'm fairly certain that whatever day Comsci exam is, I'm just gonna be downstairs and I'll hear like yes, and it'll be Kyra watching the exam paper and be like, she'll just be that happy with what comes on it. What? Alright. All I there thinking, what drugs is it on? Nice. Alright. So let's run this code and see if it's still working between last class and this class. Okay? So the menu is coming up. If we say view all players is coming up as it should. Right? If we say add a player, alright, enter this new person's first name. KISHAN MAHADIR. Alright, the 18th of the 3rd 04. Hey. Yeah. Right. All right. So All right. Playing position. All right. Let's have you as a left winger. So it says data written successfully. But we know, and I'm just running through it to show the issue again, that if we say view all players, we get in that problem where it's crashing because of the fact that the file now has that issue where we end up on this line here. How can we get a \n not to be written for the last line that should be written in the file? Right? Hmm? Yeah, no problem. How can we get that \n not written for the last line in the file? I wanna let's kind of think it through from drawing something, right? So yeah, we saving this. Let me get my drawing pad. This I should have set up before class. Mm-hmm. Yes. So that is pretty much the answer. Okay. Now let's illustrate it. Okay. All right. Well, we're going to describe it and see. Open board. Did I get it to open? All right. So hey, yes. So got it to wiki. All right. Um, all right, so we have now the situation where let's just say we're just using the IDs and the names, right? Let's just use an ID, a first name, and a last name, right? Let's say we have in the file, that's too small a file, right? So let's say we have in the file players, we have the first person 101, and we have a name John Doe. We have 102 Jane Smith. We have 103 Tom, right? Parks. So we have these three names inside of here. And we know that the objective is when we call the read file function, we have our struct array, and read file will take this content and put it into the different elements of the struct array. So we end up with John Doe here, 101, John Doe inside of a struct, right? So we have the indices 0, 1, 2. We have Jane Smith. She is 102. And we have Tom Parks, 103. And we call the read file. Now we're calling, so at this point, list at position I, right? List at position I, once I read these, will actually have the value of 3 inside of it, because 3 is the next available position. Everybody with me? All right, good. So we want to now call the add function, the add player function. Add player is going to take a player's information and put it into here. So add player, we collected information on, right, Lacey James, right, 104, Lacey James. And we put Lacey's information 104 into here, which will carry list at position I up to 4. Okay? So now we have 4 persons to write to the file. We have 4 persons to write to the file. Yeah? So we want to now call the write file function. And we know that we have to do up to the value before, actually 4, which indicates that we do have 4 because the array starts at 0. We want to write this information back to the file. So when I say, fopen the file for writing, players.txt is empty at this point, because we know that fopen on our write is going to clear the contents of the file as it exists. Agreed? We know that we're taking these granular sets of data, and we will be saying, okay, write this data, write this data, write this data. 101, John Doe, and we also say put a \n here. Right? 102, Jane Smith, put a \n here. 103, Tom Parks, \n here. What should I do for this one here? How do I know that this is the last one? How do I know that this is the last one? Huh? It is the value of list at position I minus 1. So the last one is going to be, this here is equal to list at position I minus 1. So I now could say if, right, list at position I minus 1, right, if list at list, I'm sorry, not that, sorry. If, let's say for instance, I was using a regular I as my counter to write to the file. If I, at this point now, reaches to the same as list at position I minus 1, I don't want to write a \n. But I can't write the code like that. I have to write the code saying if list at position I minus 1 is equal to I, then print to file the \n. You follow? So for this one, I print the \n. For this one, I print the \n. For this one, I print the \n. I am at the one where I is equal to list at position I minus 1. I can't write the \n for this, because list at position I minus 1 is not equal to I, because it is I. You following me? So when I reach this position here, right, my counter for writing to the file was 1, 0, 1, 2, 3. Huh? The counting? The counter. Yeah, so the counter, let me just start again a little bit. Okay? Nice. We're using 1, 2, 3, sorry. 0, 1, 2, 3. All right? So we want to write this information that is in the struct to the file. We know that we essentially say to ourselves, each position in the structure right here is going to be a line of text in the file. Yeah? So I need to have a counter, I, that will say essentially, for me to write out all of this, I'm going to say, because this is where list at position I is. We agreed upon that when we added the value, not so? When we added this one here. List at position I, placed the new person into here, and then went up to here. We did that code last class. So what we are saying though is that by doing that, we know if there are 4 persons inside here, which we say list at position I represents, and if number 4 is the next available slot, it means that the last slot with information is position 3. Yes? Yeah, it's on the board. We can all see it. All right? So when I'm saying, I'll do this. I'll say 4I is equal to 0 to list at position I minus 1. Yeah? I'm not going to the 4, I'm going to the 3. Because 3 is the last location with data. Right? So for I is equal to list at position I minus 1, I want to write this data to the file. But I want to write only this one, and this one with \n state. This last one here, I don't want to put a \n there, because that is going to give us trouble when we read back the file. Remember, we said that the file should always stop at the end of where data is written. It shouldn't stop on the following line. Right? That's what's causing our program to crash, because every time we add somebody right now, whenever we add somebody right now, this \n still gets written to the file, and it's not supposed to be there. So, however, if we remove it, then when we write to the file, everybody's going to be on the same line. That doesn't work either. So, our goal is to come up with some code that is going to put that \n for everybody except the last line. We know that the last line is list at position I minus 1. So we are saying, right, we'll say fprintf, and I'll just put data here because I'm lazy. Whatever data I want to write to the file, right, the data from the struct, and then I will check to see if I need to put that \n by saying if I is equal to list at position I minus 1, which means that if I is currently not the last position, what do I want to do? I want to fprintf a \n. Right? And if. So this is telling me for every position in the struct that is going to be written to the file, except for the last position, I want to print a \n so that the next line coming is going to be on a new line. But the last line doesn't have anything to make provisions for the next line, because the last line is the last line. There's nothing after that. So there is no need to print a backslash n. Oh, so you carry the for loop to -2, and then after the for loop, you print one line out there without the backslash n. Yeah, that will work. That seems simpler than what I was doing. Why didn't say that from the beginning? Ah. Well, we explained what we were trying to achieve. I'm still going with this too, because I don't like having to print out two printf statements, right? But again, it comes back down to you could implement something and I could implement something, and both of us do it in different ways to achieve the same goal. All right, because you could also get this done with a do while loop as well, to eliminate, to kind of as a middle ground between what you're doing and what I'm doing. Right? I think a do while loop will work as well. But because we know the amount of lines that we have to write to the file, I don't really want to use a while loop in that instance. Okay, so let's see it in code, and maybe that will work. You all understand where we're going with this, though? You hope so. That's not a very encouraging answer. Huh? You sure? Right. Maybe we'll see it in code and we'll see the difference. Right? Why is my oh, I might not be able to get out of this now. Oh. Huh? Yeah, go ahead, go ahead. Right. So we go in here. The issue was, it's a very simple issue, Anaya Cairo. It's a very simple issue. Our file, right? We implemented it in such a way that all the lines get written with a backslash n, but that causes, when we try to read a new line, it causes a file to crash. We know that the last line isn't supposed to have a backslash n on it, so that's just what we're trying to achieve. We don't want this backslash n written here. So we essentially, right, we have up to the last line here, right? This less than list I is the same as saying less than or equal to list I minus 1. They're the same thing. Okay? Sorry, minus 1, not equal to 1. They're the same thing. So I'll leave it as I had it there. If we had 4, it writes up to what is in position 3. Okay? We take out this backslash n here, and we want to put in our code that says if I is equal to list at position I minus 1. What do I want to do? I want to now write that backslash n. Right? So I'll go fprintf fp backslash n. This should solve our problem of extra data, that extra, right? That extra line coming down to the bottom like that. Because for this line now, that condition will not be met, so that backslash n can't be written. All right? I don't want to see if this. So let's add one more player and see if that works. Because so far, when we've run after adding a user, we've crashed. Hopefully, that's not going to be the case here now. So we have welcome to the player record system. Let's add a player. One, right? Let's add Andre um, Davis, Davis, right? Andre, I'm getting that you are the 16th of the 11th, 2004. 2005. What? 7th of? Andre, I'm telling you that you were born on the wrong day. Right? I feel like I was correct. Alright, are you sure that that's your birthday? Yeah. Right. Yeah, I think you need to get that cleared up, Andrew. Right. I can't be wrong all this time about all your birthdays. Alright, let's go. Alright, we're gonna put him central defensive. Let's see. 2. We still crashed. What's wrong? My code didn't work? Let's see what happened. Oh no. Alright. I ended up with everybody on the same line for some reason. No. You have to take it out here. We only wanted to write. Oh my gosh. You know what I did? I did the opposite. I put double equal instead of unequal. Which is what I had in my in the notepad that I wrote in just now. Hold on. Alright. Yeah. If we look at I need to. Alright. If we go to documents, what we wrote just now. I did have the right thing. I had if unequal to list, but just off of being Russian and doing the wrong thing, I wrote double equal sign. So this is supposed to be unequal. It actually worked as it was supposed to. Because what it did is that for the last line, look at that. For the last line, it did give a indent. So let's just fix this. And we'll try it again. So 109, 101, 107, 103, 108, 110. Right? So it wrote Andre, but Mr. Valdez wasn't paying attention and he put an equal instead of an unequal there. Alright. So let's try it one more time. Let's add another player. 1. Well, can I add it? Brandon, Dalrymple. Right. The 14th of the 2nd, 2005. Huh? Wait, the 6th of September is the 9th, 2004. Telling all your birthday is broken. Right? He's a goalkeeper, you say? Right. So if we go here now, we have the data writing out without a crash. Yay! Alright. This hanging indent that we actually see here is from in the program code because again we have a \n writing at the end there, but that is from in the program code. And it really doesn't make a difference in this instance. Right? If you want to go and put the code to not make it do the \n, the code to the new line there, that's fine. You can do that. Right? So now we have it. We have it in such a way that the file read and the file write complete. You all know what this means? This means that we can do anything with the data inside of there. And as long as we want the file to be read or written, really and truly we just have to go and put in the appropriate code for it. We don't have to worry about reading or writing anymore. We've done the function for that. And that's the purpose of using functions in C. Because imagine if it is that we had to, at the beginning of every function that we have here, write the code, put the code to read, do the function, then put the code to write. It's a bunch of repeated code. But now we have that code specialized, taken from where it's supposed to be, put into a place that we can call it, and then it will do what it's supposed to do accordingly. All right? It makes sense. It's starting to fall into place for you guys.
Yes, sir.
Right? And it's here. It's here. All I am asking is that you take the time to really and truly understand it and appreciate it before you try to apply it for yourself. Okay? And you don't have to, when you're doing your practice, you don't have to do all of this at once. Eh? You could just say, hey, I want to read a file, and write your piece of code to read the file. And you do that twice, and that stick in your memory. Hey, I want to write out something to a file. I want to see if I could read something from a file, flip all the text, and write it back. Get creative. You don't have to get an assignment from me to do it, eh? Right? Yeah, you could just say, hey, I wonder if. And it's either you could or you can't. And I don't mind if you try and you're trying to do something and you say, hey, I'm trying to do this, sir, and I'm getting it halfway. What am I missing? I would love to be interrupted by you all to get a question like that. I get out today. All right, no problem. Right? Today's what? Wednesday? Right. Yeah. So Wednesday afternoons, I'm pretty free. Okay. So if it is that you're practicing Tuesday, not Tuesday so much, because Tuesday I might have thing, but Wednesdays is probably the best day, and the next best day is Tuesday. Right? To do a little practice and say, hey, sir, I could talk to you for 10 minutes, and I'll get on a web meeting with you, and we'll see how things work. All right, yeah. Yeah, I was now about to suggest that we take like a little 5-minute breather because I've been yapping for a long time. And, right, 5 minutes there just to walk around that. Not 5 minutes like the last time, 5 minutes. It's 1:44. Everybody sitting down by 1:50. Right?